The final section we are looking at in the functions unit is the inverse of functions. So we are going to find an inverse and determine if it is an inverse function. Okay, first of all, a relation. What is a relation? A relation is any pairing of elements from one set to another. And in a function, we have pairs of every input with exactly one output. So better said, we pair every input with exactly one output, meaning that for every x, there is exactly one y value. When we have determined that a relation is a function, we can identify the function as a one-to-one or many-to-one. So what is the difference? In a one-to-one function, no output is used more than once, whereas in a many-to-one, at least one output is used more than once. Okay, so those are pretty simple definitions. Now, we're talking about relations and inverse relations. So an inverse relation reverses the pairings of a relation and switches inputs and outputs. Okay, simple terms. An inverse relation is going to take your x and y values in the relation and simply flip them, so it'll be yx in place of xy. Okay, so let's go ahead and look at some examples here. It says, from each mapping diagram, determine whether the function is a one-to-one or many-to-one. Then tell whether the inverse is also a function. So if we look at this first example, our domain, or the inputs, are -4, 0, 1, and 4. And then we have the range listed. We have -2, -3, 2, 1. Okay. When we create a mapping diagram, it is always in order from least to greatest. And you can see that these are in order. Same thing on this end, least to greatest. In a mapping diagram, we then connect each point. So you can see -4 pertains to -2, 0 belongs to -3, 1 belongs to 2, and 4 belongs to 1. Okay. Now, when we look at this function, we can tell what type of function it is simply by the output. In this case, we have a one-to-one function because for every x value, we have one y value. Okay. Now, the inverse function. The inverse function is going to take the domain and range and flip them. And you can see they are already flipped. Your range has now become the domain values, -2, -3, 2, and 1. And the range is now what used to be the domain values. So now we have -4, 0, 1, and 4. Okay. And again, if we take a look at them, even though we flip them around, 1x to 1y, x to y, x to y, x to y, right? They're all different. So in this case, the inverse is a function, okay? It is still a function, originally was a function, it stayed as a function because it is a one-to-one, okay? Now, if we take a look at the second example, B, we have the domain, -4, 0, 1, and 4, and we have the range, -2, -3, 2. You can see that -4 belongs to -2, 0 belongs to -3, 1 belongs to 2, and 4 also belongs to 2. So in this case, we have a many-to-one function. Okay. Now, finding the inverse of the function, we flip them, and you can see the domain and range are now listed. -2 now belongs to -4. -3 now belongs to 0. 2 belongs to 1 and 4, right? Remember, we had two x values to one y value. When it was flipped, we have one x value to two y values. In this case, because you are sharing two outputs to one input, the inverse is not a function. Okay? In order to be a function, you must have a one-to-one relation. So based on your conclusions above, what must be true about a function for its inverse to also be a function? As I just stated, it must be a one-to-one function in order for the inverse to also be a function. All right, now let's go ahead and look at some graphing here. We have the function, and it is listed. You can see the coordinate points. Our function is -4, -2, 0, -3, 1, 2, and 4, 1. Okay, it is essentially, it's the same as a mapping diagram. Our mapping diagram simply took the x values, in this case, -4, 0, 1, and 4, right? And then it took the y values, -2, -3, 2, and 1. That's how we come up with a mapping diagram. This one, we were given the coordinate points, so we are going to find the inverse by simply flipping them. Our first coordinate point, -4, -2, is now going to become -2, -4. Okay. Second coordinate point, 0, -3, becomes -3, 0. Third, 1, 2, becomes 2, 1. And the last one, 4, 1, becomes 1, 4. Okay. Now, if you look at the graph over here, you can see that we have the line drawn. Remember, a diagonal line with a slope of 1 is always going to be the equation of y equals x. And we have the original function graphed. So we have -4, -2, we have 0, -3, 1, 2, and 4, 1 already plotted. We are now going to graph the inverse function with the coordinate points that we found. So if we graph -2, -4, that's down here, -3, 0 up here, +2, +1, and 1, +4. Okay. Now, if you take a look at those points, what do you observe about the graphs of a function and its inverse in relation to the line y equals x? All right, so think about it. Let's start with our first point here. -4, -2, the inverse was -2, -4. 0, -3, the inverse was -3, 0. 2, 1, inverse, 1, 2, inverse was 2, 1. And the last one, 4, 1, inverse is 1, 4. So if you look at those points and the way they are plotted, you can see that they are reflections of each other over the line y equals x. Okay, so when we have a function and its inverse, they will always be a reflection of each other over this line.